So today, first of all, we'll start with a small topic of hydrolysis of salt, which you may have learned in the 10th standard also. So please write the topic. Hydrolysis of salts. Now, we know that salts, they are made up of acid and base. Acid and base, it forms salt. And depending on what kind of acids we are using, what kind of base we are using, that salt will have a certain pH of its own. So when we use a strong acid and a strong base, the salt we get is neutral, and the pH of that salt is 7. When we use a strong acid but a weak base, that salt in nature, and the pH of that salt is going to be less than 7. Next condition can be if we use a weak acid but a strong base, that salt is going to be basic in nature and the pH is going to be more than 7. But when we use weak acid as well as weak base, the salt is going to be, you don't know really. Like for that, we have to check whether the pK or pKb, what is higher, what is lower. So for that, we have a formula. The pH of that salt will be equal to 7 plus half of pKa, sorry, minus pKb. So the difference between pK and pKb, and if you add 7 to it, half of pK minus pKb plus 7, that is going to give you the pH of a salt which is made by weak acid and a weak base. Okay? So very simple. Please copy this down. Raise your hand once you're done. Please copy this table down. Raise your hand once you're done. So Deja, waiting for you. Okay. Now, a very related topic to this, that is the next topic that we have to understand is regarding buffer solution. Right, the heading. Buffer solutions. So what is buffer solution? So basically the definition is also very important. The solution that resists change in pH. Change in its pH will be better. In its pH, when small amount of acid or base, small amount of acid or base is added to it. ठीक है, small amount of acid or base is added to it. ठीक है. अच्छा, एक चीज ध्यान रखिएगा यहाँ पे please, that a buffer solution, it will have its own pH. It's not necessarily going to be 7 or 8. ठीक है, ऐसा सुन के ऐसा लगता है कि when we talk about buffer and it is not going to change its pH, तो पता नहीं, this is the concept that pH क्या होता है, 7 होता है. ठीक है. But it is not like that. Buffer solution will have its own pH. It may be more than 7, it can be 7, it can be less than 7. It doesn't matter. But whatever be the pH, for example, 6.4, 4.6 is the pH के buffer मिलते हैं generally. So if we are going to add a small amount of acid, the pH will not change. So it is a very interesting type of molecule, buffer solution. And the inspiration of buffer is taken from blood. So we eat all type of food, but and like no matter where the humans are coming from, we eat different things, right? And whatever blood is being made, whatever cells we have, it is all because of whatever we eat. And we eat different types of food, but the pH of the blood, it does not change. Even if you drink a lot of soda, that soda is almost acidic in nature, because you have carbon dioxide. You digest carbon dioxide with water, it will give you carbonic acid, but that is not going to change the pH of the blood. So this notion of a solution which does not change its pH is coming from where? Is coming from the human, not human blood, but in general blood of any organism. So now the problem is, how can we make buffer? Because this can be useful if we understand this concept, that there can be solutions that in which you add, and it is also kind of fascinating that you are adding acid, but it is not changing its pH. So until a certain range, of course, not like you can add no matter how much amount of acid, and it is not going to change the pH, but small amount of acid is not going to change its pH. So how to make the buffer, that is an important concept that we have to understand. Now, although I can go into detail about the complete, starting with like complete scratch, that okay, fine, we have to make a solution which cannot change its pH. That means when we add H positive, then something should happen which should reduce the amount of H positive, and when we add a base, that means we are adding OH negative, then there something should be there which is going to combine with OH negative, and it should reduce the amount of OH negative. So all of those talks we can start, and slowly I can build up directly. I can build up slowly organically, that okay, fine. So these are the conditions for buffer. That means we can use this compound, we can use that compound, but not, it's really not the time that I go into details. So I will just go with the textbook definitions of buffer and how to make buffer, and hopefully you will understand it. So buffers are of two types. Generally hate this type of teaching, but still we cannot go into very much detail. Otherwise, it is very interesting to start from the scratch. Okay, fine, we have to use some compound like that and like this. Okay, but and it would require like larger attention from you guys also. You should be attentive throughout the 15-20 minutes. You cannot zone out anywhere. So textbook, they are of two types: acidic buffer and basic buffer. So first of all, we'll understand acidic buffer. Also, the conception of buffer, that how the brain should work when it is preparing a buffer, that is not really in the syllabus. Also, syllabus is concerned with how the buffer works. Like after you have made the, first you assume okay, fine, this is a buffer, then you will understand how the buffer works. Okay, that is there in the syllabus. That I will go into complete detail, how acidic buffer works and how basic buffer works. Okay, now what is an acidic buffer? So acidic buffer will contain, please write with me, contains equimolar mixture of weak acid. So we are having a weak acid. Okay? We are having a weak acid and its salt with strong base. So we are having an acid and its salt, weak acid and its salt, strong base. The pH of acidic buffer, it is obviously less than 7. Now, one example that we have to go into detail is the buffer of acetic acid and sodium acetate. For example, we have acetic acid plus sodium acetate. Okay. Now, both of these things are inside water, ठीक है, दोनों चीज पानी के अंदर है. So when we have acetic acid and sodium acetate, there are two equilibrium which exist. एक जो equilibrium है, that is CH3COOH from acetic acid. It will dissociate into CH3COO negative plus H positive. The other we have is CH3COONA, that is sodium acetate, and the equilibrium will be existing between CH3COO negative plus Na positive. Now we can clearly see here that in this particular buffer, we have a huge amount of, unnecessarily huge amount of CH3COO negative ions. हमारे पास CH3COO negative तो बहुत ही ज्यादा है, ठीक है. Now, first thing is that what is going to happen if I add an acid to it, like how it is going to neutralize the effect of acid. Here you are going to write on adding acid, that is H positive, ठीक है. H positive आपने डाला. On adding H positive, CH3COO negative will combine with H positive and form undissociated acetic acid. ठीक है. अब undissociated, this acetic acid एसिडिक नेचर तब तक शो नहीं करेगा जब तक कि H positive डिसोसिएट ना हो जाए. Until and unless the H positive is dissociated, it will not show its acidic nature. That is why we will say that when H plus combines with the acetate ion, this ion, it is neutralized. H plus क्या हो गया है? Neutralized हो चुका है. H plus is neutralized and form undissociated acetic acid. Therefore, neutralizes the effect of एसिड के इफेक्ट को उसने न्यूट्रलाइज कर दिया. अब हमारे पास दूसरी चीज है, व्हाट विल हैपन इफ आई ऐड अ बेस. ऑन एडिंग बेस, that is OH negative, that is OH negative, the H plus will combine with OH negative. अच्छा, एक चीज और यहाँ पे ध्यान दीजिएगा. There is one more equilibrium that already always exists whenever we have वाटर इनसाइड ना, तो पानी का इक्विलिब्रियम भी हमेशा एग्जिस्ट करेगा. H2O is auto ionized into H positive plus OH negative. ये भी हमेशा एग्जिस्ट करता रहेगा, ठीक है. Even though in a very smaller amount, if I compare with the above two equilibriums, but this equilibrium is also existing, and that is why what would happen when we add H positive, then these two will combine with each other, H positive and OH negative. Sorry, when we add OH negative, then what will happen? These two will combine with each other, and this equilibrium will be shifted on the left side. So what would happen? On adding base OH negative, H plus would combine with OH negative, and the and एक second, and as the concentration of H positive decreases. लीजिए यहाँ पे कि whenever we are adding OH negative, तो H positive combine करेगा. H positive जब combine करेगा तो आपको समझ में आ रहा है ना, H positive की concentration decrease हो जाएगी. And when the concentration of H positive is going to decrease, तो pH change होगा. But as the concentration of H positive decreases, the reaction 1, जो कि आपका ये पहला इक्विलिब्रियम है, जो आपके पास पहला इक्विलिब्रियम है, the reaction 1 would shift in backward direction. Backward? No, my bad. Forward direction. Because concentration कम हो रही है प्रोडक्ट की, shift in forward direction. And increase the concentration of H positive and therefore neutralize the effect of acid. No, sorry, effect of base. समझ रहे हैं? On adding H positive OH negative, H positive OH negative साथ कंबाइन करेगा, H positive OH negative के साथ कंबाइन करेगा तो इसकी कंसंट्रेशन घटेगी. Concentration घटेगी तो pH बढ़ना चाहिए था, but what would happen as the concentration of this particular equilibrium, concentration of H positive in this particular equilibrium decreases, Lee-Chatelain principle के according this reaction will move toward the forward direction, और forward direction में move करेगा तो H positive concentration वापस से regain हो जाएगी and you will be neutralizing the OH negative also, जो कि हमने पहले ही कर लिया है. So this is the working on how it works. This complete acidic buffer ये किस तरह से काम करता है. Please write this down. Raise your hand once you're done. Please raise your hand once you're done. Please raise your hand once you're done. Yes, Khadija and Khudeja, जल्दी लिखें please. Done, Khadija? Okay, Khadija is done. Khadija, just waiting for you now. Next है यहाँ पे pH of the buffer solution if they have given you the concentration of some of the species. ठीक है. So जो pH होता है बफर का, it majorly depends on the acid because we are having weak acid. उसका major component होता है. So we know that the concentration of rather an acidic buffer के लिए आपके पास एक weak acid होगा that will be having an equilibrium something like this, H positive plus A negative. Now, as the dissociation constant of acid is given by the concentration of चलिए H पॉजिटिव पहले multiplied by A negative divided by the concentration of HA. Now, here, if I talk about the concentration of H positive like this, then it would become Ka multiplied by A negative will go down, Ha will go up, Ha upon A negative. Now, if I put log here, log into concentration of H positive will be equal to log of Ka multiplied by Ha upon A negative. Now, if I separate these two, this will become log to the concentration of H positive will be equal to log of the dissociation constant of the acid plus log of the concentration of the acid Ha divided by the conjugate base A negative. Now, if I put up a minus sign in all of these things, तो ये हो जाएगा minus log of H positive minus log of Ka minus, or rather I can write plus itself, but cos minus log अंदर जाएगा तो ये reciprocal हो जाएगा इसका. So plus log of the conjugate acid upon the acid, conjugate base upon the acid, sorry. So minus log of H plus is nothing but it is the pH, minus log of Ka is nothing but rather it is pKa, plus log of concentration of conjugate base divided by the acid. Not the acid, but the concentration of acid. Please copy this down. This is for acidic buffer. You can raise the hand once you're done writing. In this equation, it is also known as Henderson-Hasselbalch equation. Copy this down and raise your hand once you're done. Waiting for Khudeja now. चलिए, now a very similar thing we can write for the basic buffers, जिसको आप यहीं पे लिख लें. Similarly, for basic buffers, we will be completely dealing with bases, and I hope you can understand when we deal with base, then we talk about POH. When we deal with base, we will be talking about PKB plus the log of, instead of the conjugate base, we will be having the conjugate acid and divided by the concentration of weak acid है ऊपर, यहाँ पे क्या जाएगा, base आ जाएगा. Now, I mentioned this here because you can see that you can compare it and you can tell, okay, fine, we can get the pH of the basic buffers also. But we know that what is the pH? pH is 14 minus pOH. So if I want to talk about the pH of a basic buffer, that will be 14 minus whatever the pOH is, and pOH is this whole term, minus the pOH. What is pOH for basic buffer? This, so the whole term for basic buffers, pOH. So this will be the formula for the pH of basic buffer. This is the pH of acidic buffer. This is the pH of basic buffer. So quickly write this down. Raise your hand once you're done. Just waiting for Khadija now. चलिए, नेक्स्ट आप लिखिएगा. देखिए, बेसिक बफर का हमने यहाँ पे हेंडरसन हैशलबैक इक्वेशन दोनों को कहा जाता है. आई हैव टॉक्ड अबाउट द हेंडरसन हैशलबैक इक्वेशन हियर, बट लेट्स अंडरस्टैंड व्हाट इज बेसिक बफर नाउ, है ना. अब बेसिक बफर थोड़ा सा देखते हैं. चलिए, प्लीज राइट द सेकंड type of buffer that we can have is basic buffer. ठीक है. Basic buffer, it contains सही से लिखते हैं, equimolar mixture of weak base लेंगे हम, and it's salt with a strong acid, and it's strong acid. ठीक है. अब एक एग्जांपल जो हम लोग को पढ़ना, दैट इज NH4OH, ammonium hydroxide plus the salt ammonium chloride, NH4Cl. Now, the equilibrium that exists in this particular solution of the weak base and salt with strong acid is, first of all, NH4OH will be in equilibrium with NH4 positive plus OH negative and NH4Cl will be in equilibrium with NH4 positive plus Cl negative. अब नेक्स्ट यहाँ पे जो वर्किंग है वो ऑलमोस्ट सिमिलर है, दैट व्हेन वी आर गोइंग टू ऐड अ बेस, फर्स्ट ऑफ ऑल बेस जब हम डालेंगे, then what is going to happen, the NH4OH will be combining with the OH negative और ये बैकवर्ड जाने लगेगा and it is going to form uh, undissociated NH4OH. ठीक है, तो फर्स्ट ये आपके पास, दिस इज द सेकेंड। ठीक, इसमें सबसे पहले हम सिंपल टर्म्स में लिख देते हैं, ऑन एडिंग OH negative first equation will shift backward direction। आपने जो ऐड किया OH नेगेटिव वो क्या हो जाएगा, इट इज गोइंग टू शिफ्ट इन द बैकवर्ड डायरेक्शन। नाउ व्हाट इज गोइंग टू हैपन टू ऑन एडिंग H positive, on addition of H positive, it will combine with OH negative and the first equation will shift forward direction, in forward direction। ठीक है, तो इस तरह से ये कुछ न्यूट्रलाइज करेगा। H पॉजिटिव डालिए तो OH नेगेटिव कंबाइन कर जाएगा, तो OH नेगेटिव कंसंट्रेशन घटने लगेगी तो ये इक्विलिब्रियम फॉरवर्ड शिफ्ट कर जाएगा। ठीक है, चलिए प्लीज कॉपी दिस डाउन, रेज योर हैंड वंस यू डन। Just waiting for Khudeja now. Basic once again, please. Okay. So, what do you want to understand, Khudeja? The working. Yes, Khudeja, you want to understand the working? Acha, fine. So, whenever we test a buffer, उसमें हम दो चीज करते हैं ना, either we can add H positive or we can add OH negative to change the pH of a solution. So if you are going to add H positive, तो ये H positive जो है ना किससे combine करेगा, OH negative से। Why? बिकॉज वेन एवर यू एड एच पॉजिटिव इट इज गोइंग टू कंबाइन विद OH नेगेटिव। उसका काम ही क्या है? बिकॉज जो पानी है आपका ना, वाटर इट इज नॉट अ स्ट्रॉन्ग इलेक्ट्रोलाइट, इट इज अ वेरी वीक इलेक्ट्रोलाइट. So H plus and OH negative ions, if they are present in a solution, they won't be present in a solution in a very high amount. They will be very minimum, negligible amount में H positive और OH negative present होते हैं. So as soon as you are adding H positive, it is going to combine with OH negative जो कि हमारे पास यहाँ पे है. Here we have OH negative. ठीक है? So अब when you are adding H positive, it is combining with OH negative. अब क्या हो रहा? OH negative की concentration कम हो रही है. When the concentration of OH negative is going to be reduced, then the pH will change because OH negative concentration कम हो रही है. OH negative concentration ज्यादा होगी तभी. So concentration of OH negative is reducing, तो क्या हो जाएगा? pH change होगी. Now, but that won't occur. जैसे ही OH negative की concentration कम होगी, वैसे ही ये reaction जो है ना, this reaction will go forward and it will produce more amount of OH negative because हमारे पास NH4OH बहुत ज्यादा है. ठीक है? It is what? It is also weak base. ये this will be present. ये पूरा का पूरा dissociated नहीं होगा. There will be some amount of NH4OH which is undissociated, and that NH4OH is going to dissociate and form OH negative because OH negative concentration कम होगी. This is Lee-Chatterjee principle. अगर आप प्रोडक्ट की concentration कम करेंगे, then the reaction will move forward. ठीक है? I hope the addition of H positive is clear. What happens when we add OH negative? जब आप OH negative add करेंगे, then अब क्या हो रहा है यहाँ पे? द कंसंट्रेशन ऑफ OH नेगेटिव इज इंक्रीजिंग. कंसंट्रेशन ऑफ OH नेगेटिव इंक्रीज करेगा तो दिस रिएक्शन विल मूव द बैकवर्ड डायरेक्शन. अब जब ये बैकवर्ड डायरेक्शन में मूव करेगा तो कंसंट्रेशन ऑफ OH नेगेटिव अपने आप ही क्या आ जाएगी? नीचे आ जाएगी. इट विल फॉर्म अनडिसोसिएटेड NH4OH. डज दिस मेक सेंस नाउ कि कैसे इट इज बैलेंसिंग द effect of addition of acid as well as base? Yes or no? Khudeja, you got it? Please copy this down. Raise your hand once you're done. ठीक. नेक्स्ट जो टॉपिक है आपके पास दैट इज सॉल्युबिलिटी प्रोडक्ट. बट बिफोर गोइंग इनटू दैट टॉपिक, इज सॉल्युबिलिटी प्रोडक्ट डन इन योर स्कूल? बिकॉज बहुत सारे स्कूल सॉल्युबिलिटी प्रोडक्ट नहीं कराते हैं. यस, खदीजा एंड फुदेजा, दिस इज द टॉपिक. इफ यू solubility product, just tell me in the Zoom chat yes or no. KSP, have you heard of these words? Solubility product, KSP, have you heard about these words? Yes or no? Yeah, ये chapter, is this chapter? I hope no. Okay. What about you, Khodeja? Is this done? नो. ठीक है. अब एक बार आप लोग और रीचेक कर लेंगे. सी एक्चुअली देयर इज वन, ये लाइक इट्स वन लेक्चर. अगर पूरा का पूरा सॉलिबिलिटी प्रोडक्ट पढ़ना है तो बिकॉज सॉलिबिलिटी प्रोडक्ट है, देन वी हैव KSP, then we have prediction of whether the precipitation of a particular salt is going to take place or not. So these are complete like small topics जो कि solubility product के अंदर पूरा का पूरा आता है. So अब आप एक काम ये करेंगे, नेक्स्ट क्लास जो होगी आपकी दैट विल बी ऑन थर्सडे. वी विल बी स्टार्टिंग विद द रिविजन. और आप लोग को काम ये करना है कि यू आर गोइंग